Hello everyone. Let us see the electric field intensity due to infinite line charge related problems and solutions. Before we step up further, you know very clearly that electric field intensity of a straight line conductor at the point P having infinite length oriented along Z axis is specified by rho L divided by 2 pi epsilon naught AY. Of course, the unit is volt per meter. This is actually taken in the Cartesian coordinate system, and the AY is the unit vector along the direction of or the distance r, which is perpendicular distance of the point of observation P from the source. The source is line charge. So AY can be considered as AR, right? And R is the distance. So electric field intensity at a point P at a distance, vertical perpendicular distance of R units along y-axis, when the source infinite straight line conductor is situated at along z-axis, rho L divided by 2 pi epsilon naught into R AR volt per meter, right? The field intensity at any point has no component in the direction parallel to the line which the charges are located, where the line charge is infinite. What do you understand from the statement? The line charge is parallel to z-axis. E will not have a z component. Will not have a z component. Therefore, if the infinite line charge is located parallel to, for example, y-axis, definitely E will not have, okay, will not have any ay component. So RAR is all about only the perpendicular distance from the infinite straight line. To understand this concept, we shall take up a problem. Say, for example, a uniform line charge with rho L is equal to 25 nanocoulombs per meter. It lies on the line x is equal to -3 and y is equal to 4 meters in free space. Let us calculate electric field intensity at a point P whose coordinates are given by 2, 3, 15 meters. How to calculate it? So let me first of all represent the line charge. For example, the line charge is an infinite line charge. Where is it located? Along x-axis. If you check, this is the line r -3 along x-axis, and this is the point at which y is equal to 4. And can you recognize one more condition, that the point of observation is available at, for example, p is equal to 2, 3, 15. Wow. Z axis, y axis. The line with the x is equal to -3, y is equal to 4, y is equal to 4 is a constant. It's a line parallel to z axis. Therefore, Z can take any value along the line. Charge is infinite line charge. Electric field density due to an infinite line charge at P is specified as rho L divided by 2 pi epsilon naught R into AR volt per meter. Yes, we know. To find R now, there comes a question R, because once I estimate R, then only I can identify what is modulus of R, which is equal to small r, magnitude. Once you calculate these two, you can obtain AR. AR is obtained as a ratio of vector R to the modulus of vector R. So all these things start from the computation of vector R. Consider 2 points. One is the line in which along the line the coordinate will be x is equal to minus 3, y is equal to 4, and z can take any value. And the point of observation is 2, 3, 15 meters. So, and I just want to tell you, even if you calculate this, the source line charge is parallel to z axis. Therefore, E cannot have any component in A z direction. Hence, Z need not be considered while calculating the vector R, because R, magnitude of R, AR, all these things will be substituted finally to find out what is E. So, I tell you like this, as the line charge is parallel to Z axis, E cannot have component in Z direction. In the sense, AZ component will be missing. Therefore, no need to calculate Z related terms. Okay, so let me find out. One point is minus 3, 4, Z. The other point is 2, 3, 15, point of observation. So vector R is 2 minus 3 AX plus, yes, 3 minus 4 AY. Of course, I should have gone to the next one, but Z need not be considered. I have told you already, because it is parallel to Z axis. Infinite line, straight line is parallel to Z axis. Computation of Z related components will obviously be cancelled in future, because we will say AZ will not be present. So if you take this, this will become 5AX plus minus AY. Okay, good. Vector R is ready. What is magnitude of R? This is equal to square root of 5 squared plus minus 1 whole square, which is equal to root 26. So what is AR? It is 5AX minus AY divided by root 26. Okay. What about E? Due to infinite line at P will be given by rho L divided by 2 pi epsilon naught into SR multiplied by AR volt per meter. So vector E is equal to rho L is 25 into 10 power minus 9 divided by 2 pi into 8.854 into 10 power minus 12. And of course, what is the magnitude of R? R is root 26 multiplied by 5AX minus AY to the half root 26. So the answer will be, yes, 25 into 10 power minus 9 divided by 2 pi multiplied by 8.854 into 10 power minus 12 multiplied by 26 into, yes, 5AX minus AY, right? So this can be finally expressed as 86.42 AX. You can cross verify 17.284 AY volt per meter. Okay, yes. With this idea, I can go for one more problem. An infinitely long straight conductor with the uniform line charge density is located at y is equal to 3 for a change. Z is equal to 5 units. If rho L is equal to 30 nanocoulomb per meter. Find electric field density at origin and electric field density at, say for example, another point 0, 6, 1, like this. So understand this problem, how to represent the given data in a diagram. So let me have. Okay, so rho L is equal to 30 nanocoulomb per meter. Along Z axis it is 5 units. Along Y axis it is 3 units. So it is going to be parallel to X axis. This is Y, this is X, and this axis is Z. So the charged line is parallel to X axis. Therefore, E cannot have any component in X direction. Hence, don't consider X during calculation of vector R, magnitude of R, AR. Yes, because the problem has to be ultimately solved using computation of R, computation of magnitude of R, and of course AR, and finally they have to be substituted into E. This is the sequence. So I'll start with point of observation is at the origin. The source is located at Y is equal to X comma 3 comma Z is 5, right? Between these 2 points, I have to establish what is called as R vector. So R vector is 0 minus 3. I told you already X need not be considered because obviously the line is this infinite straight line conductor is situated parallel to X axis. So AX component will not be present, cannot be included for the calculations as per the derivation. So we simply consider the AY component and what else? AZ component alone. So I say this is minus 3AY plus, or I should say minus 5AZ. Look at the computation. So what is magnitude of R? This is square root of 3 squared plus 5 squared, which is equal to root 34. 9 plus 25. What is electric field density due to a straight line conductor at a point 0, 0, 0 is given by rho L by 2 pi epsilon naught into R magnitude and the perpendicular distance to the point of observation from the source. So it is equal to 30 nanocoulomb per meter, 2 pi into 8.854 into 10 power minus 12. Okay, root 34. Now you just see this. The vector is because how will you compute AR? AR is computed as R by magnitude of R, right? Minus 3AX minus 5AZ divided by root 34. So my dear students, it would be minus 47.58 something AY and 79.3 AZ volt per meter. Reduce this. Electric field density due to an infinite straight line which is situated parallel to X axis and the point of observation is at the origin. The vertical distance vector is minus 3AY minus 5AZ. So obviously the magnitude of this vector is square root of 34. So the result will be this one, right? So this kind of computation may also vary if electric field density at a point, for example, instead of origin, if somebody says compute the electric field density due to this what is called as infinite straight line conductor with a uniform charge density, maybe at a point 0, 6, 1, then there are only a few variations when you consider the point sources at x comma, what is it? It is at x comma 3 comma, yes, 5 is the point at which the source is available, whereas the Point of observation is at, say for example, 0, 6, 1. So obviously, of course, we don't involve the first component because the straight line conductor is parallel to x-axis according to the diagram. So I take only 6 minus 3 ay and plus 1 minus 5 az. What is the net result? So you will get 3ay minus 4az. Magnitude of this vector is square root of 3 squared plus 4 squared, which is equal to 5. Right. So you tell me, what is AR vector? It is vector by the magnitude. So it is 3ay minus 4az by 5. 3 by 5 minus 4 by 5. Now, what is the electric field energy? It is equal to the T into 10 power minus 9 divided by 2 pi into 8.854 into 10 power minus 12 multiplied by 5 is the distance, magnitude of the distance, 3ay minus 4az to the top 5. So you have to find out this is, say for example, 64.71 ay minus 86.28 az. Did you notice one thing? It does not have any component along x-axis, right? All right. Thank you.